Hi everyone, my name is Aaron, and in this video we're going to continue developing our tower defense game with the primary goal of teaching you certain bits and pieces of Python programming. So by the end of this video we're going to have lives and money. This is what we're going to achieve in this video. Let me show you how. Those who have been following these videos previously know that we already have a maze in place and we have enemies running up and down in there, but it's still not a game because there is no goal, there is no risk, there is no decisions to be made, so it's basically just an engine right now. In this video we're gonna make it different. Let me show you what the end result will actually be. So by the end of this video, we're gonna have lives and money that we have to invest wisely, and we can buy turrets just as before. Now I'm gonna buy one sniper, and I can see that I'm not in a great position because the enemies are headed to this spot, and this is kind of a risky situation. Each enemy gains or earns me 30 money, and I have 3 lives, so if 3 enemies reach this point, I'm dead. Now with some money in the bank, I could actually buy one more turret, a machine gun, but I'm gonna wait just a little more until I have 100 money. Please, no, I'm losing 1 life there. Boom, there you go. Now I only have 2 lives. I'm setting up the next sniper, and now I'm safe. So the first thing that we actually had to do was register the number of lives and the amount of money that the player starts the game with, right? Nothing fancy here. These are just instance variables, nothing new or unexpected. We have one difference in the turret selection, because when we click select turret, we are not going to see all of the turrets, just the ones that cost less than the amount of money that we actually have. So we are not even creating button for the turrets that we cannot buy. Let me show you that in practice real quick. I'm gonna put up my usual sniper, as I always do in the beginning. And now I have 0 money, so no matter how hard I click, nothing happens because I have no money. Now I have 30 money. It's still not enough because a machine gun turret is 50 money. Now I'm gonna shoot 1 more enemy, and then I'm gonna have enough money to buy a machine gun. So I'm clicking here, but only the machine gun appears because a sniper turret costs 100 money, and I don't have that much, so I'm just gonna be left with a machine gun, okay? This is what this code snippet does. It iterates through all the turrets and checks for their price and checks if their price is actually less or equal to our money so we can buy it. This is the easiest way that we don't even display buttons that will not function. However, there is one very important thing here, and this is the main primary lesson of today's video. These here are turret classes. Don't forget that we have classes, which are kind of like the blueprints for objects, and then we have instances, which are actually memory reserved for the variables of that specific object that have the same value, the same structure as the class prescribed. But these are classes. There is no memory reserved for them, right? These are just blueprints. And yet still here, when I'm going back to the select turret, I'm actually comparing the price of a turret class against the current money of the player. How is this possible? Let me show you how. This thing is called a class variable. Look at this. Here I have the class declaration for the turret class. And normally we always began putting functions here, but now between the first function, which is traditionally the init function, and the class header itself, I have put 2 variables, a price and a name. And here a little bit of a secret kind of gets unveiled, because in Python, and like I mentioned before, everything is an object. And the classes themselves are actually objects, meaning they are instances and they do have memory space for themselves. And the class variables are actually happening on the class level. Each instance has a copy of these variables without any action in the init function, but the class itself also has a copy of them, okay? So this is how you can put attributes to instances of a given class regardless of the instance itself, just copying it over from the class. So this way we can guarantee that every single instance of the turret class and all of its descendants, machine gun, sniper, all have these variables in place. Let me show you what I did here. In the sniper turret, I actually overrode the name and the price as well. Okay, this time is the same price, but in the machine gun, I overrode both the name and the price, okay? This is how class variables work. And with these, I can actually compare the variable inside the class to any other variable. It's just like a normal variable, okay? It's a bit against what we have been speaking about so far, meaning that classes don't have variables, instances do. Yes, actually classes do have variables and they are very useful sometimes. If you want to save an attribute that is true to every instance of a given class, you can use class variables for that. Okay, awesome. Okay, other than that, we also needed to take account of the lives being lost. How do we lose a life? We lose life when an enemy makes a move, and as a result of that move, the enemy reaches their destination, right? That's when we lose a life. So we have changed the signature of the enemy.move function. A signature is the incoming parameters and the return value together. That's what we call a signature. We changed the signature, so now the move function, a little bit illogically, returns the number of lives lost. Of course, if an enemy doesn't reach a destination, it's taking 0 lives away from us, but let's see how that is implemented. So in the enemy class, the abstract base function of move actually takes count of the lives lost, and whenever an enemy reaches the destination or does something else, because in the future we might have very different enemies that take our lives in a different way, it's all up to the make movement function. Therefore, the signature of that function is also changed, and that also has to return the number of lives lost, which is by default 0. And then if you go to the creeper enemy, which if you recall is just going around randomly, it has no actual movement, it always returns 0, and I have even made a remark here that says creeper can never take a life from the player. So that's the old enemy that was kind of harmless. But let's see the runner, and in case of the runner, we have to figure out when we reach the destination that the runner was headed towards, and once we do that, we actually kill the kill the enemy. So the runner that reaches its own destination dies. Why? Because that's the easiest way to get them off the map, right? Otherwise, they would still be lingering around, or we would need a separate mechanism to remove them from the game. They are no longer valuable because they have fulfilled their destiny. Instead, we just kill them, and therefore they are removed by the remove dead enemies function. And then we return 1. That's the only case when the player can lose a life, when the enemy reaches its destination. If the enemy did not reach its destination, then of course we don't take a life away, okay? So this is the mechanism for the player to lose lives. And then of course we subtract the number of lives lost. And once we ever reach the point where the player has no more lives, we are stopping the running of the loop that updates the game itself. Please note that I'm using less or equal, even though theoretically we have 3 lives and we can only lose 1 in one movement, so we should not be able to lose more than 1 lives and thus go into negative. However, in the future we might actually have a situation when, for example, 2 enemies reach the goal in the exact same tick, and then we decrease the number of lives by 2, and if we had just 1 life, we would have -1. If we would only compare to 0, we would not register the player as dead, effectively making it immortal. So this is called defensive programming. So if you are assuming that things will be exactly the way you expect them to be, that can sometimes be wrong, and you want to prepare for a broader set of cases by, for example, using less or equal instead of just equal, okay? It's called defensive programming. Also, please note that I did a little refactoring. After the turrets attack, we remove the dead enemies, so the enemies that have been shot should not move anymore. And after the enemies made their moves, and might or might not have reached their goal and therefore might have died, I need to remove the dead enemies again. Therefore, this function is invoked twice. And just one more addition here. If we have lost all our lives, again comparing to less or equal to 0, then we display this very simple game over screen for 3 seconds. This, by the way, is not good programming practice, honestly, because your screen always have to react to events that happen on it, right? And if you invoke sleep, that means your program is frozen, it cannot react to anything. And typically that's when you get those windows that say the application is not responding, do you want to kill or wait or whatever else, depending on your operating system. If I would make this sleep 10 seconds, that window would surely appear because that's too long a time for an application to not respond. 3 seconds is usually okay on a desktop system, okay? Here we go. Removing the dead enemies. Oh, and there is one more very important change. It's a good thing that I'm looking at it. The enemies that get killed pay us the reward, right? They drop loot, and that's how we can buy new turrets. So what we need to do is actually collect the dead enemies before we remove them, then make the registry of living enemies free of the dead ones, right? That's what this list comprehension does. But I need to save the dead enemies before I do that. And for all the dead enemies, I actually have to collect the money, increase my current money with the reward that I get from the enemy. Reward is a class variable, but since class variables get copied to the instance, it is also an instance variable because here, this enemy is actually an instance of an enemy class, right? Doesn't matter, class variables are present in both the class and the instance. Okay, these are all the changes we needed to do in the game itself. And I have also briefly mentioned the introduction of the class variables to the enemy. Of course, there's also the turret, because the turrets now have a price and name. Okay, that's out of the way. In the enemy class, I was considering to make the reward a class variable, right? I could easily do that, no problem whatsoever. Each and every enemy and all the descendants of the enemy class and their instances need to have a reward, right? But it is not actually necessary. I don't need to do that. And personally, myself, I don't really like class variables. I tend to avoid them as much as possible because when you are looking at an instance and its variables, you can see where they are coming from. If there is an inheritance, for example, in case of the runner that inherits from the enemy class, the init pretty much shows what I override. It's doable, no problem. Yeah, I personally don't like them, that's just all. And so here I have added the reward that can be overwritten. Of course, the runner is worth 30 money, gold, whatever you like. And the creeper, I think it's only 20 money. Yeah, exactly. So that's a bit cheaper or gives less reward. Of course, you can go ahead and tweak it to your liking. That's the way the enemy rewards the player for shooting them, basically, or drops the loot or whatever you like. Of course, we don't have any graphics yet. Please don't forget that the game is available for download. The link to the repository is in the video's description. If you want to go ahead and give it a shot, please feel free to change, tweak, do anything with it. It's open source. So this is the way we have introduced class variables and also made this an actual game where you have a task, a challenge that you need to fulfill. Of course, it's still not far from complete because we don't have levels and a whole lot of other things. It doesn't get any harder. Once you set up your turrets, they just kill the enemy and you have nothing else to be done. So yeah, it's still in its infancy. But in the next video, I'm gonna do graphics and maybe even sound design. So I hope I'm gonna see you in the next video as well. That's all for now. Thank you for watching. Bye.